Okay, we're going to look at trying to solve these trig integrals. The first set will be of the form the integral of sine to a power and times cosine to a power. Could be just sines, could be just cosines, or a mixture here. So if we have the powers where both m and n, if one of them is odd or both of them are odd, we're going to use the Pythagorean identity and get it down to a single power of one of the trig functions and then do a basic substitution. Okay. If both m and n are even, it's a little trickier. We're going to have to use the half angle formulas to reduce the powers in half and then try to do some subsequent simplifying, maybe some other identities. So let's look at the first case here. And the first case, as I said, if we have one power or either power that's both odd. And I said we're going to use the Pythagorean identity. This is where our most common identity, sine squared of x plus cosine squared of x equals 1. And what we're going to do with that is, depending on whether we've got cosines or sines that we want to get rid of and change them to the other. Notice they're always going to come in pair. We can change two cosines, or I should say, a pair of cosines to a pair of sines to a pair of cosines, something like that. The key being we want to get down to a single power, either of sine or of cosine, okay? And let me show you what I mean by that. With this example here we've got sine squared of x times cosine cubed of x. And so because I can only convert things in pairs, I could either convert both of the sines into cosines, which would leave me with all cosines, right? Or I could convert two of the cosines into sines and leave me with a cosine left. Now the key is, the reason with the odd powers is you always want a singleton left over. So what we're wanting to do is, in fact, then deal with the cosines and convert things that way. So we're going to use then, really change this then and think of it so it's a sine squared of x times cosine squared of x times another cosine of x. So there's our cosine cubed. And now we're going to change this cosine squared, and that's going to be changed into a 1 minus sine squared. Okay? So when we rewrite this now, we have the integral sine squared of x, and this is now 1 minus sine squared of x times cosine of x dx. And then we'll multiply things here, distribute here. So we have the integral of sine squared of x minus sine to the fourth of x, and then all of that times cosine of x dx. Okay, so we've got our singleton cosine. And this is where now we want to put our substitution in, and we're going to let w equal sine of x, and then dw is cosine of x dx, right? So this becomes the dw. And notice here, that's going to be a w squared and a w to the fourth. So our entire integral now is the integral w squared minus w to the fourth, and then the rest was a dw. Very easy antiderivative, right? A 1/3 w cubed minus 1/5 w to the fifth plus c. And now we can put in the fact that the w is really a sine, so it's a 1/3 sine cubed of x minus 1/5 sine to the fifth of x plus c. And that's the answer to this one.